In the previous video, we discussed Bernoulli's principle. Now we will take a look at a few practical examples of Bernoulli's principle. An airplane wing demonstrates Bernoulli's principle. The velocity of the air just above the wing is higher than the velocity of the air just below the wing, since the air on top of the wing has a further distance to travel in the same amount of time. Since the velocity is higher on top, the kinetic energy is also greater on top. This means that the pressure must be lower above the wing, otherwise Bernoulli's principle wouldn't hold. Below the wing, the speed is slower, so the kinetic energy is lower, which means that the pressure has to be higher. So we have relative high pressure below the wing and relative low pressure above the wing. Since the pressure below the wing is greater than above, this causes lift and helps keep the airplane wing in the air. Another example of Bernoulli's principle is a curveball in baseball. The rotating baseball drags a layer of air immediately next to its surface. If we see the ball is rotating clockwise, then just above the ball, the air speed is reduced due to air being dragged by the ball in one direction and the velocity of the airstream pointing in the other direction. If the airspeed is reduced just above the ball, we will have an area of relative higher pressure. Below the ball, since the air and the air being dragged with the bottom of the ball are both traveling in the same direction, the speed increases. With an increase in speed, we also have an increase in kinetic energy, but a decrease in the pressure. Since there is lower relative pressure below the ball than above the ball in this example curves downward. One last example of Bernoulli's principle is a small engine carburetor. The butterfly valve or the throttle valve is the throttle plate. The throttle plate controls engine speed. You open it to increase your engine speed or load and close it to decrease the engine speed or load. A carburetor acts like a venturi. It creates a low pressure region in the throat. Since the area is smaller, the speed is faster, which means the kinetic energy is greater, so the pressure has to be lower by Bernoulli's principle. Since the pressure is lower, this draws fuel out into the lower pressure area. As the fuel is drawn into the low pressure area, it must have higher kinetic energy, so that must mean that the particle's speed increases here as well. As the particles move faster, the pressure drops some more in the throat. As a side note, when fuel enters the low pressure region, it vaporizes, since it must be in vapor form to burn. This concludes our discussion on fluid flow and Bernoulli's principle.